3.4. At some temperature, resistance is given. At what temperature, what is the resistance? At 0 degree Celsius? 5 volts. Okay, so that is R0. T0 seconds. Fine, next.
100 degree Celsius. 5.79.
તારી બુકમાં ઇક્વલ છે આમાં અલગ હતા 5.23. Okay, then temperature and the resistance is
5.795.
so alpha is not given here. If alpha is not given, we will make two cases, two equations, and then we will divide. Alpha will get cancelled. So first of all, this is the reference. This is first one and second one. So we make an equation for the first one. For delta, so delta R is equal to what? R0 alpha delta T. Okay, so delta R means R1 minus R0. Okay or not? Is equal to R0 alpha delta T means T1 minus T0, and similarly for second one R2 minus R0. Okay, divide it. So alpha cancelled, R0 also cancelled. Understood? Back here. Get out. Infinite ladder or એમાં શું પ્રોબ્લેમ કે the curve very present that day when we did for capacitor the same બરાબર મેં કરેલું એટલે તો હોમવર્ક માં પેન્ડિંગ કરવું. Okay, exercise question 3.1. Exercise question 21. It's about infinite ladder of resistors.
મોટું ચાલે છે હાથની સાથે સાથે
Please turn the fan on. Have some mercy on me. So this is what we have. આ બાજુ infinite, બોલી બાજુ infinite. Okay. So suppose this is A and B here, and this is P and Q. So if we will consider the equivalent resistance between A and B, let's say that is X, let equivalent resistance between A and B be X, or you can also say R equivalent. Same follows you. Then if you remove this portion of A and B and you want to make the circuit look exactly the same, देखो यहाँ देखा आ गैप से 1 ohm થી ચાલુ થાય and then there are something and then once again there is the 1 ohm. So if you want to make it look exactly the same, what you have to do is you have to erase this part A out. So what would it look like then? Same thing starts with P now and with Q. So I have removed the other part. Did you understand? And then here the same thing follows. I got negative. Is it fine? Now the equivalent resistance of this circuit is also X. So equivalent resistance of the circuit shown here is also X. Right? So we are going to draw now. So what will it do? 1 ohm, 1 ohm, 1 ohm. हाँ तो एक काटने के लिए બાકીનું x. And the equivalent of all this is also x. So solve it, put it equal to x, and solve that quadratic equation. Fine. Then it becomes a typical. Next, S1 3.9. So you are unbalanced with 30. What's the problem there? Current direction માં problem. એ તો assume કરવાની. બોર્ડ એક્ઝામ માં પૂછાશે તો આમ જ કરવું પડશે because there is no other method described in the book. બરોબર ને? તો પૂછે રોહન તને કહો છો હવે શું બીજું શું પૂછ્યું છે કરંટની ડાયરેક્શન માં શું પ્રોબ્લેમ છે I don't understand your question. So I1. Okay. So here, first of all, in figure we are not given any of the values, so it's completely up to us. 3.9 from the x-axis. અહીંયા શું છે કેટલું રહે 10 અહીંયા 5 પછી અહીંયા વચ્ચે 5 10 how many volt બીજું કઈ છે okay so suppose in this branch current is I and in this branch current is I mean I1 and I2. So this current will reach here. Okay, at this point this will be still I1. And then this will be I2 going here. First of all, do you understand that by symmetry we are writing this as I1? And similarly by symmetry, if this is I2, then over here also I2. Fine. So હવે તો કઈ બાકી નથી. Look at this one. I1 coming in, I2 going out, and here we can either choose downwards or upwards. The choice is ours. Book માં figure માં કઈ નો આપ્યો question માં આપણે કહો એમને જાણો. So suppose we take it right now as the arrow shown in the book. છે ને કઈ arrow shown to there downwards. If you take it downwards, then how much is this unknown current? આપણે કેવી find? Nothing but doubt. Yes or no? Or is it just that you don't like this method? Huh? You don't like this method? એમાં શું તે એવું ટફ તો છે ને બરાબર ને કે નહીં? Then you have to make equations and solve them out. Okay. Then of course you can also do it by assigning voltages to different points. જે ઓલો આપણે triangle શું ઓલો y shape વાળો ક્વેશ્ચન કર્યો હતો તો આમાં થાય but that would not be valid for body. Okay. Next. Here. Yes, Priyank. Okay. Little bit better. Engage little bit.
સર બે રજિસ્ટર આપેલા છે એમાં રો ઇક્વિવેલન્ટ ફાઇન્ડ કરવાનું.
They are same in length.
હા
Areas are A1 and A2.
હા
Okay.
તો કેવી રીતે કરવાનું?
So equivalent resistance. Good question.
નથી સર રેઝિસ્ટિવિટી.
હા વાંધો equivalent resistivity ને
હા
guess करूँगा ये calculation of it looks like it's going to be rho 1 A1 sorry rho 1 by A1 plus rho 2 by A2 upon 1 upon A1 plus 1 upon A2. So there are two wires. Let me explain the question to everyone so everyone can pay due attention to what's going on here. So there are two wires, they are connected in parallel. First has cross-sectional area A1 and resistivity rho 1. Second has cross-sectional area A2 and resistivity rho 2, but their lengths are same, let's say L. get that? They are connected in parallel. We have to find out the equivalent resistivity. We have to find the equivalent resistivity. Meaning to that. Equivalent means this and this should have same resistance. So they will do the same thing in every way. Correct? So our area is A1 plus A2. Is that okay or not okay? Yes, A1 plus A2. Why? Because this one had area A1 and this one had area A2. So A1 plus A2 is area, and then the equivalent resistivity is rho, and length will be how the parallel method. These two are in parallel, let's get this. So 1 by R should be equal to 1 by R1 plus 1 by R2. And 1 by R is equal to that. Rho equivalent, rho simply, okay? So now into L upon A, A1 plus A2. No, I go. Okay, 1 upon R1.
A1 upon
So 1 upon rho 1 L A1 plus
A2.
rho 2 L A2. Alright, so therefore A1 plus A2 on rho is equal to A1 by rho 1 plus A2 by rho 2. L cancel. By rho find out, therefore rho is equal to arm that. Divide. Take this as one bracket. So that's going to be A1 plus A2 upon A1 by rho 1 plus A2 by. Okay, આમને કયા ફોર્મ માં કોઈ તને ખબર આવું જતું કે
Rho 1, rho 2, A1, A2.
હા તો LCM લઈ લે. So if we take LCM, rho will be equal to A1 plus A2 upon A1 rho 2 upon A2 rho 1, and then this will be multiplied with rho 1. Okay? Next.
સર આવો સિરીઝમાં તો ત્યારે એરિયા શું લેવાનો?
બેનો એરિયા A હશે ને તો એરિયા A લેવાનો ને લેન્થ L1 plus L2 લેવાનો. Like this. So first one L1 L2
સર એમ નહીં, બંનેની લેન્થ સેમ, એરિયા શું લેવો?
series માં બેની લેન્થ સેમ અને
એરિયા ડિફરન્ટ.
there can never be made equivalent. Equivalent no meaning to that instead of 2 if you connect 1 it should be exactly the same. બેનો એરિયા સેમ નહીં હોય તો પછી equivalent નો એરિયા તમે કેટલો રાખો? would you take it A1 A2 અને એવરેજ લેવાનો કોઈ જસ્ટિફિકેશન નથી. You understand what I'm saying? Equivalent resistance find કરી શકાય but not equivalent resistivity because the area won't. तो એવું કહી શકે કે whatever area is there we have to fill it up all. So एक और लोग for example they say that there are gaps here, okay, and one gap is here and we have to now fill it all the way from here to here. Then you can make one given that you know how much area you have to fill. We need to know that information, how much should be the area for the equivalent.
Exercise 3.13.
Exercise
3.13.
1-3. એમાં શું આવ્યું?
Power 40 આવે, 10⁻³ આવે છે formula.
ઓકે રાજ એમાં કેલ્ક્યુલેશન મિસ્ટેક હશે બીજું કંઈ નહીં હોય. વાંધો નહીં કરી દો છો. આ તો ખાલી તને કહો છે એમાં કંઈ ન આવડે એવું તો લગભગ કંઈ થાય એવું છે. ચાલો જોઈ લઈએ. Number density of 3 electrons is given. Question 13. N is equal to 8.5 n raised to 28 per meter cube. This is like this. How long does the electron take to drift from one end to the other end of the wire or something? How long is the wire? 3 meters. So first of all we will find out drift velocity. Area is given, length is also given. Okay. How much will be drift velocity? That we will know by current. I is equal to NEAVD. So it is equal to I upon NEA. Fine. And the EVD. So that VD we can take for drifting. So you get time interval delta t will be equal to delta x by VT. Right? Okay. Time interval delta t will be delta x by VD. So I think you delta x into 2 N E A upon 5. Delta X is a 3 meter. I'm just doing it over here. 3 meter multiplied by 8.5 10 raised to 28 into 1.6 10 raised to minus 90 into 2 into 10 raised to minus 6 divided by 3. 3 cancel. Okay. 8.5 into 70. 70, 16, the 16 into 272. You got it? 17 into 16, 272. Okay. So 2.72 into 27.2 into 10 raised to 28 minus 19 minus 6 is there. Minus 9 and 3. 27.2 into 10 raised to 3 units versus second. So answer is what? On the left.
2.7 into 10 raised to 2.
You multiplicate it now. Right? Yes, next. Good. Guru. Ayan. Nobody. Final call. Check point it out away. All right. Let's continue with the lecture material. बाकी है ना जी कैसे What was the last one we did? 70. થઈ ગયો ને તમારે આન્સર આવ્યો કે ન આવ્યો નથી આવતો મેથ આવતો નથી ઓકે વેર ઇઝ 70 લખી ગયો નહીં મેળો નથી કેમ ન મેળો થેન્ક યુ so supply voltage is 120 and the lead wire here you can consider it to be like internal. That's what was given, and there is a 50 watt bulb which is already connected, and in parallel with it we are connecting a heater. How many watt heater? 240. So we have to find the decrease in the voltage across the bulb. The decrease in terminal voltage. पहला आने कनेक्ट न करो ओपन स्विच ऑफ okay this is 60 watt and now we are using simple idea that this is rated power then rated voltage will be how much rated voltage will be 120 so any 40 into resistance of the bulb how much will that 120 into 120 upon 60. Yes or no? So that is 240 ohm. Okay? 240 ohm. Now, that's the resistance of the bulb. Now we will also find out resistance of the heater. But current find. Resistance of heater 240 watt. In the change of 120 upon 240. So that's going to be 60. Yes or no? Or not clear? Take it in. R2 side. Fine. Chalo. હવે શું ફાઇન્ડ કરવાનું છે individual terminal voltages. For that we'll have to find out current. First situation, only this is connected, that is not connected, and this 6 ohm. So in the first situation with only bulb, what's the current flowing here? I1 or whatever that is. I1 equal to epsilon upon R plus R. Epsilon is 120 divided by resistance of this one is 240. 240 plus 240. Is it okay? This is okay. Leave it there. Okay, now both that is bulb and heater. So I1 is equal to epsilon upon. Okay. This time also formula is same, but the values are different because R equivalent આ બેનું આવશે ને 240 and 60 are in parallel. So that 240 by 5. You can say 48. Right? 24 to 40 to 60 upon 300. You can 10 cancel, 10 cancel. Yeah, 48. Yes. 48 plus 6. Agreed? Yes or no? So we will do this is 120 upon 54. Okay, so this is the curve. Now if you want to find, there are two different ways to it. If you want to find the decrease in terminal voltage, you can either use the IR formula or you can also use the epsilon minus I smaller formula. Okay, I will go by epsilon minus I smaller. So V1 minus V2, decrease V2. Epsilon minus I1 R minus epsilon plus I2 R. Understood? Change of sign. Whatever then. This minus this. Got it? So by change of sign we got this is going to be I2 minus I1 into R. I2 minus I1 into R. So what is I2? 120 by 54. 120 common. 1 by 54 minus 1 by 246 into internal resistance. 6 of easy option 7. What's taking a risk? They are not so close. Calculator over take a second in that. This is 54. And yeah, both of these I think can be divided by 3 or you can take something common. Whatever those 6 common cut off. Like 6 are 1 by 9 minus 1 by 41. And 6 will get 10. Somebody guys? Okay, over those I can 41 minus 9 32 upon 9 into 41. Okay, this can be divided by 3, so this is 40. Okay, so this is how much? 4 into 1, so 1280 upon 123. In like 10 point something else is 13 तो नहीं आ रहा. Agreed? तो आ जाए. Is it fine? D. Okay, 18th question. Figure shown each resistance of video. હવે ચાલુ કરી લો કોણ હોતા 40%. करिए ना नेक्स्ट क्वेश्चन. राजू. Okay. Lots of resistors are given. Then rate of joule heating in the circuit means power. Power is the rate of heating means power. We have to find power for the whole circuit. You have to find power for the whole circuit. How many volt batteries are there? 10. And negligible international resistance. Okay. Okay. Nevertheless, so we know that 10 volt battery is there. So if I want to find the total power of the circuit, do you realize we do it like this? કારણ કે ઇન્ટરનલ રેઝિસ્ટન્સ છે નહીં ને એટલે ખાલી v² બાય r ઇક્વિવેલન્ટ કરી નાખીએ. r ઇક્વિવેલન્ટ ફાઇન્ડ કરવાનું. હરી ઓફ 1. Pick series parallel. There is definitely something which is in series or in parallel. So, did you find out R equivalent?
Yes.
How much is it?
8 by 11.
Correct, 100 by 11.
R equivalent.
100 by 11.
So 100 by 11.
લાસ્ટ બેચ પર બેસીને આમ સોલ્વ કરવાનું જૂનું સ્કૂલનો ટાઈમ યાદ આવે. આમ બેટા આરામથી તો કરાવતા જોતા કોઈ બુકનું કંઈ ટેન્શન જ નહીં, પડી ગઈ સાઈડમાં અને આમ સત માઇન્ડમાં બધું હાલતું હોય. પછી તો અડધો કે નહીં પેલા સર આમ એવું બધું છેલ્લી બેચ પર બેઠા બેઠા કોઈ ડિસ્ટર્બ જ ન કરવા આવે અહીંયા. તું કે કપલ Isn't the R equivalent 100 by 11? નથી આવતું? મેં તો પેન વગર કરી લ્યો, ખોટું પડે તો તમારે દેખાડવાનું. આવે છે 100 by 11. પછી તો પાવર આવડી જશે ફાઇન્ડ કરતા. Let's go to next question. Or not? Go to the question no છે. Who has got the answer? Okay. It's all about identifying actually. Others may start doing the next one. Jo. એકદમ ક્લિયરલી ઉપરના બે પેરેલલ છે. યસ ઓર નો? એનું થઈ ગયું. હવે રાઈટ સાઈડ ના ત્રણ છે ને એ પેરેલલ છે. યસ ઓર નો? આમ આડું કરી નાખો પેપર પછી જો. The three are in parallel. દેખાણું કે ન દેખાણું? Clear? So 20 20 20 parallel માં શું થાય? 20 by 3 અને 20 20 parallel 10 10 અને 20 by 3 are in series. એવો હશે ને? Sure? 10 and 20 by 3 are in series. So કેટલું થાય? 10 and 20 by 3 in series કેટલું થાય? 50 by 3. Yes, 50 by 3. And that 50 by 3 and the remaining, they would slant say 10 ohm. They are in parallel. So it equivalent find करना होगा. Okay, question 19. Arrange the order of power dissipated in the given circuit. એટલે શું find કરવાનું? Power loss. And you have to arrange them in order, right? Options are shown. Okay. So, first one, given that every resistor is R, તો ફર્સ્ટ માં ટોટલ પાવર શું આવશે? હા
3 square by r. 3 square by r.
એક ચારે સર્કિટ જો ઇઝ વોલ્ટેજ ગિવન એક એ મને નથી ને વોલ્ટેજ એટલે બધું કરંટ ઉપર જ છે so do not use voltage related equations because voltage may be same may be different for all but current is same so first માં શું આવશે
I square r by 3.
I square r by 3 I square r by 3 I square r by 3 yes or no what is the equivalent resistance r by 3 and the current is I so I square r by 3 thank you okay log in outside I square r by 3 so a second 3 I square r thank you third
3 by 2 I 3 I square r by 2.
હવે 4
2 by
3 third થઈ ગયો ને 3 by 2 I square r જો આવે છે third માં હવે 4
2 by 3 I square r.
ah equivalent will be 2r by 3 so I square into 2r by 3 okay so arrange them which is maximum second is maximum એટલું જ આવશે ને and minimum is first one એટલું તો ફિક્સ થઈ ગયું so which option only first one એનો ઓર્ડર જોઈ લેજો 3 4 નું બરાબર છે ને એમ નહીં તો ખાલી કન્ફર્મ કરવા માટે બાકી તો બરાબર આન્સર આગળ એ આવશે કાં તો કઈ નહીં આવે ઓકે ક્વેશ્ચન 20 બરાબર બરાબર I'll give you a hint. Here you should see what is same amongst the resistors. એનાથી તરત compare કરી શકો. Okay, if current is same, then H is I square RT એ રીતે use કરે. If voltage is same, then V square by R and into T એ રીતે. Okay, depending on what is same and what not. So in the circuit shown in the figure, heat produced in 5 ohm resistor due to current flowing through it is 10 calories per second. Power I would say. Power or heat relations are ideas are there. So how much is the power in 5 ohm? 10 calories per second. Based on that, you have to find how much is the heat generated in ohm. Okay, lower branch માં suppose current I1 એવું માર્ક કર નાખો. Then how much will be current in upper branch? એમાં નો કરાય પછી બીજી વાર સોલ્વ નહીં કરે. Lower branch current is I1. Then how much will be the current in upper branch? Huh? This is only a part of circuit. Remember, current આમથી આવે છે left side માં દેખાય arrow. If in lower branch current is I1, then how much will be the current in upper branch? Raise your hand, चलो. Confidence રાખો. Raise your hand. એમને તો બોલો છો. હવે એ બોલો. I minus તો I ખબર છે. નહીં તો exact value છે.
I minus root
I
minus root 2.
I minus root 2. તો root 2 ક્યાંથી લાવ્યો છો? વેલ્યુ થી. તો I શું છે? I want exactly the value. આટલું તો root 2 ફાઇન્ડ કરી શકતો exact આવી જ જશે. If this is I1, if lower branch is I1 current, then upper branch current is very simple. Fine, no problem. What's the resistance of lower branch? Upper branch? Okay, they are in same to હોય same to હોય voltage yes or no so if voltage is same then current is inversely proportional to resistance agreed or not તો નીચે 5 ohm છે ઉપર 10 ohm છે તો નીચે કરંટ I1 હોય તો ઉપર કેટલો છે I1 by 2 correct or not half હશે ને resistance is double so current will be half clear તો નીચે I1 ઉપર I1 by 2 understood હવે ફાઇન્ડ કરી શકો આન્સર પાવર ફાઇન્ડ કરવાનો છે, ભલે હીટ લખ્યું યુનિટ જો કમ્પેર ધ ટુ એક 5 ઓહ્મ અને 4 ઓહ્મ ને કમ્પેર કરી નાખો પાવર માં એટલે આગળ બી
બી આવશે કરંટ ને
હા
ઓકે ઓપ્શન બી
2
હા
so this how it going to work out. Power in the 4 ohm upon power in the 5 ohm is equal to current in the 4 ohm કેટલું છે I1 by 2 square એટલે 4 into resistance is 4 divided by I1 square into R. Is this clear or not clear? Now P4 I square R P5 I square R. Got it or not? કઈ કરતે I1 square cancel પછી 4 4 cancel હવે P5 ની વેલ્યુ છે P5 ની વેલ્યુ છે again 10 equal to this. Understood? Yes or no? Sure? समझ पड़ी ने तेनो समझ पड़ी करंट ની વેલ્યુ ફાઇન્ડ કરવી હોય તો ફાઇન્ડ કરી શકાય but there is no need really, that is even without doing I1 we have been able to get them. Okay, next question 21 કે હજી વિચારો છો આમાં શું કેવું છે no confusion whatsoever. 21 So the question means that there is a heater and with the heater we are going to connect a bulb. એવું છે ને? Okay. In what series or parallel? Series. And then everything is connected across the supply. Correct? And what do we want? We want maximum power. Yeah. Maximum heater output means maximum power for the heater. બરાબર ને? Maximum output or maximum power for the heater. Okay, power maximum કરવા માટે શું કરવું? For a particular device, suppose our heater. Okay, and I am going to connect some bulb and the bulb is unknown. Unknown means we don't know anything about the bulb, let's assume. Okay, this is a question mark. We can put whatever we want. But I want the power for this heater to be largest possible. So what should be more? If power for the heater should be more, what should be more? To make the power more, current more. Sure. If current will be more, will power for the heater be more? Voltage should be more. Equivalent resistance should be less. Yes or no? Suppose આનું કઈક રેઝિસ્ટન્સ છે R અને આનું કઈક રેઝિસ્ટન્સ છે R. So do you realize that power for this particular heater should always be equal to I square into RH, correct or not? RH cannot be changed, but RP can be changed because we can use different bulbs. એવો છે ને question નો meaning. Meaning is clear, we can use different bulbs and we should make the power maximum. So our power maximum કરવા તો current should be maximum. You can also go by this, right? There is nothing wrong with it. Where in the logic is, if current is maximum, voltage will be maximum voltage. V equal to IR. Clear? So either the current should be maximum or the voltage for this heater should be maximum. But still, I say this is preferable. There is no reason. Ano and ano current because these two are in series. Did you get that? So easy for a calculator. બોલું ખોટું નથી but it is stupid. So what થઈ ગયું? Now to make power maximum, current should be maximum. So equivalent resistance should be more or less.
Yes.
less, sure, because if resistance is less, current is more. So we are charge માંથી કયું suitable છે, which will give equivalent resistance smaller. આ resistance છે તો શું છે? તો પછી decide કરો કોનું resistance ઓછું હશે. Which bulb has more resistance and which has less resistance? A, B, C or D? D will have
Less resistance.
less resistance. How can you decide? The power is more. Confused करो કે ન કરું? Power is inversely proportional to R. તમે તો એવું કરો છો.
રેટેડ વસ્તુ માટે એની માટે ફોર્મ્યુલા છે ને
હવે બરાબર. For the rated power, the resistance is inversely proportional to the rated power. બરાબર ને? What the formula of resistance of a particular device or bulb? Power, voltage rated squared upon power rated. Correct or not? Yes or no? So that's why what you said is correct. That if power will be more, resistance will be less. बाकी वो एमने पूछे तो ट्रैप में न पड़ी जाता. Is power directly proportional to R? No. Is it inversely proportional to R? No. ये कहीं साचुं नहीं. It's neither directly proportional nor inversely proportional. Depends on the situation. Okay or not? So like trick question. Suppose there is a 50 watt 200 volt 200 or 100 volt bulb. Okay, this D, and there is another 100 watt 100 volt, and you connect them in series. Understood? Okay, and then let's say that series supply is suppose 200. Okay, गमे तो anything बहुत में question ना meaning में होता है. These are the bulbs. Which will glow brighter? Which will glow brighter? Whichever gets more power will glow brighter. Yes or no? तो बोलो तो तुमने लगे. करो सवाल करो. Question है क्या कहीं? એમાં જ વિચારવાનું એવું નથી. It's a well made physics question. Which bulb will glow brighter? Again the hint is whichever gets more power will glow brighter. सीधी बात. जल्दी कर दो सीधું પછી પેરેલલ में कराओ. B1 will glow brighter. Are you sure? B2 will glow brighter. Do you have proof? पहला B2 कनेक्ट है. आप भी लॉजिक है. ध्रुव बात बोले तो पहला B2 देख आते तो पहला પછી क्या होता? B1 has more power. So Prima is sticking to her statement. Do you have proof? Interesting. B2 proof. તેને પ્રૂફ કરો બરાબર. વ્યવસ્થિત ફાઇન્ડ કરો વેલ્યુઝ. જરૂર પડે કેલ્ક્યુલેટર લો કઈ વાંધો નહીં. તો the nice learning exercise for scattering intuitions. हाँ બે સરખા જ આવશે. Sure. Do you have proof? Proof વગર બોલે તો કઈ મતલબ ત્રણ જ પોસિબિલિટી છે. લો ઓફ ટ્રાઇકોટોમી. Yes or no? B1 greater than, I mean power 1 greater than power 2. Power 1 equal to power 2 and power 1 less than 1. તો પછી B2 નું રેઝિસ્ટન્સ ઓછું છે. કરંટ એને વધારે મળશે. Of course. So એ વધારે બ્રાઇટ. चलो कर दो. नहीं. Maths is your friend. Equal values ફાઇન્ડ કરો ને પછી ક્યાં કઈ ગેસ સ્પેક્યુલેશન કઈ રહેતું જ નથી, બધું કેલ્ક્યુલેટ કરો એટલે પટ દઈને થઈ જાય.
Sir, B1 will be more brighter.
B1 will be brighter than B2.
Yes.
કર્યું ને પ્રૂવ કે નથી કર્યું? How many times bright? Double. B1 will be double brighter than B2. એવું કે double. કે B2 will be double brighter than B1.
2.5 times brighter.
2.5 times. એક નવું લાવ્યો પ્રિયાંશ. હા કરી નાખું મોટું થાય ઘરે જવાનું. કેમ કે turn it off.